So what we're going to do is look at the graph of cotangent. Now, having just looked at the graph of tangent, one might think that they are very similar to each other, and they are in a way. Also, one thing to notice is that cotangent is the reciprocal of tangent, and we're going to be able to explore what reciprocals look like when we know the graph of the original function. So some good things happening here. So let's just take it step by step here and just remember a couple things. So cotangent, remember, in terms of simpler trig functions, is cosine over sine. Now, turning my attention to the denominator, I'm noticing, hey, wait a minute. This means cotangent also has undefined spots. In fact, it's undefined when sine of x is equal to 0, when the denominator is equal to 0. Now remember, when we graph sine, we notice that all the x-intercepts of sine were at the integer multiples of pi. So this is going to mean x is equal to 0, pi, and I'm going to say 2 pi. I think I originally intended 2 values to go there, but I'm sneaking in a third one just because I can. So another thing to remember is that cotangent is the reciprocal of tangent. Now, to get a sense of what's going on with cotangent here, and again, I'm going to put this here as my y-axis because it basically belongs there. I'm going to make a little mini table here, just of some special values of x versus tangent x, just so we can look at what happens with cotangent. So when x is 0, remember the tangent of 0 was 0, which means cotangent is undefined at 0. Now that's a little different, right? And we had pi over 6, pi over 4, pi over 3, pi over 2. And I'm just going to look at those first 90 degrees, and then we'll see what happens after that. So pi over 6, tangent was 1 over root 3, which means cotangent is root 3, the reciprocal, right? At pi over 4, tangent is 1, cotangent is 1. The reciprocal of 1 is itself. At pi over 3, we had square root of 3, which means here we have 1 over root 3. Now, pi over 2 is kind of a weird one, but I'm going to call that undefined for tangent. But remember, cotangent is cosine over sine, right? So that means that cotangent of pi over 2 is cosine of pi over 2 over sine of pi over 2, which is 0 over 1, which is 0. So even though tangent of pi over 2 is undefined, cotangent is defined and is equal to 0. So plotting those points, let's just see what happens here. So pi over 6, about a third of the way between 0 and pi over 2. The y value is root 3, which again is about 1 3/4. At 1, we have 1. So pi over 4, we have 1. And at pi over 3, we have 1 over root 3, which is a little smaller than a half, so we're probably about there. And then at pi over 2, we're at 0. Now, if we kept this train running here, what we would notice is the following. There is actually a vertical asymptote at pi. Remember that tangent of pi was 0, so that means cotangent is going to be undefined. And remember that when we moved into second quadrant angles, that the value of tangent was negative, which means cotangent is just going to be the reciprocal of negative values. So there is one swing of the cotangent graph. Now what that also means is that this is going to repeat itself. Tangent has a period of pi, so does cotangent. So that just stands to reason. So cotangent is kind of the same as tangent, except it's going the other way. It's going down all the time instead of up. And there is what 3 periods of cotangent looks like. Now let's look at all the important stuff. So the period of this graph is pi, and that is to say that if we're cotangent of bx, it would still be pi over b. The domain is all reals except, well, what do we have here? We have asymptotes at every pi. So it means x not equal to k pi, and I'm just going to leave it at that. The range is still all real numbers, which we call negative infinity to infinity. We have asymptotes where the domain is restricted. So x equals any integer multiple of pi. And the x-intercepts, I'm just going to call plus or minus the odd pi's over 2. Which, remember, we can write in a fancy way, 2k plus 1 pi over 2. Okay? Oh, and that's comma 0, of course. So there's all the ins and outs of cotangent. I just want to make sure, yep, here's all the ins and outs of cotangent. So come back for cosecant and secant, and then we'll be done with all the trig functions. How about that?